a little bit about polymorphism. Polymorphism is a pretty difficult topic. A lot of people are very confused by it. They don't really understand what it means. So let's try to break this down and really understand what is polymorphism. Well, polymorphism, the word comes from the word many, poly meaning many, and morph meaning form. So what it really means is many forms. And it's still kind of a confusing concept to a lot of people. I think if you ask a developer, I know I've been on both sides of an interview asking the question and being asked the question, a lot of the response will come out something like, well, if you had a shape and then you had a square and then you had a draw method and so on down the lines, describing an example instead of really understanding what is polymorphism, what is the base concept of it. So I'm going to try to make this as simple as possible. There's two components to polymorphism. You have some code that's dependent on some kind of interface. And when I use the word interface here, I just mean some method of operating with it, some way that that code is being used or that class is being used. An interface for a class is simply just the methods that exist on that class. So you have some code that's dependent on some methods that exist in a class or some methods that are defined. And then the second component is that you have behavior of that code is determined by the actual class that's implementing that interface. So what that means is that when you actually use that code that's dependent on the interface, what the methods that it's going to call, they're not preset. We don't know what they are. That code doesn't know what they are or what they're going to do. Instead, what happens is when that code runs, depending on what type is actually implementing that method or that interface, that's what's going to happen. So a good way to think about this is if you ask someone to give you something to write with, an interface would be something that writes, and they hand you something, and you don't know what it is. When you ask, if you ask a question, give me something to write with, you might get a pen, you might get a pencil, you might get a marker. All of those things are able to write. Think about it as the write method. But depending on what you get is what gets put on the paper is what it's going to look like. So if you got a marker, it might be a thick markery line. It might be a red line if it's a red marker. If you got a blue ballpoint pen, it's going to be a small blue line. If you got a pencil, it's going to be a pencil line on that paper. So that's really what polymorphism is. It says, hey, I'm as the user of the code that's using some interface, I don't know what you're going to give me. What actually implements that interface, or what I actually get, is what's going to determine the behavior. So let's look at an example of this. In this case, I have our animal class here, and our animal class has a method called makeNoise. A lot of animals make noise, so we have a base method in our animal class called makeNoise. Now we're going to use inheritance here, and we have a dog and a cat, and they both inherit from animal. They're both types of animals. So what we're going to do here is for dog, we're going to override, we're going to redefine that makeNoise method, and we're going to put out bark. We're going to make a dog bark. And for cat, we're going to redefine the makeNoise method, we're going to override that, and we're going to have a meow. And so if we had some code that was using animal, we don't have to specify in that code. That code doesn't need to know whether it's working with a dog or a cat. Instead, it will program against the animal's interface, which is against an animal type with a makeNoise method. And at runtime, when we run our code, if we have actually assigned our animal to a dog instance, then it'll do a bark. If we've assigned it to a cat instance, it'll do a meow. So really polymorphism is just that ability for, at runtime or dynamically, for that code to be able to call whatever method is implemented by the class that inherits from the base class, whatever the real class is, the underlying type. So that's a real simple way, and I'm going to show you how we can actually do this in code. So let's extend our printer example a little bit further here, and let's look at polymorphism. So what we're going to do here to set this up is we're going to go into our machine class, and we're going to basically make polymorphic behavior on this turn on method. And the way that we're going to be able to detect this is we're going to print out when the machine turns on a certain message, and we'll print out a different message when the printer turns on. So we'll do system.out.println, and we'll say machine is on. So now what we can do to demonstrate this is we'll go ahead and create our printer, but the way that we're going to create our printer here is we're going to use a reference to machine. So instead of creating our variable type as printer, we're going to use machine. Since a printer is a type of machine, we can just actually use the printer or the machine. This machine variable can hold either a printer or a machine. Anything that inherits from machine, anything that is a machine can be held by this variable. So we're going to actually create a new printer here, though, even though this code is going to act on it as if it's a machine. And we'll call machine dot turn on. So let's go ahead and run this. And you can see that machine is on is printed because printer doesn't have a turn on method. It's using the one that's inside machine. Now, let's see how we can actually make this polymorphic. If I go into our printer class and I override, which is to create a new implementation for the turn on method, then we should see that turn on method for the printer is going to be called instead of the one for machine when we're using a type of printer. And in Java, the way that we override a method is we use this attribute here, or this annotation in Java called override. And you don't actually have to use this, but this makes it so that the compiler will check to make sure that when you put it here, if you don't override a method that actually exists, if your override isn't going to work, it's going to give you a warning, it's going to give you an error. So I'm going to create a method called turn on, and it has to be the exact same method signature that exists in the parent. And in Java, all methods are virtual. What that means is that I don't have to tell the compiler that this method can be overridden, that we can have a method that is going to override this in our subclasses. Instead, by default, all methods are virtual. So this method is going to be called if the type is of printer. So let's go ahead and change this turn on. Let's make sure that we call our super turn on so that it still does actually turn on the printer. But let's change our message here, and let's add an additional message besides what was happening in the machine. Let's go ahead and do system.out.println, and we'll print warming up print engine. And let's go ahead and change the order here so that we're actually warming up the print engine before we actually turn on the machine. So now I'll go ahead and run this, and we still have a reference to a machine here, but because the type is printer, it's going to use the printer's turn on method. So you can see that it said warming up print engine and then machine is on. So it has actually called this method, and it determined which method to call based on what this type was. So we can prove that that's true by changing the type here. If instead of a printer, we change this to say new machine, and we say true, or we can say false here to start it in the off state, and we run this, you can see that it's now set to, it's now just saying machine is on. So it's actually calling the method inside machine. And that's really what polymorphism is it's this ability that based on what type this variable is assigned to, even though this variable itself is actually a machine type, is holding reference to machine type, if this is a printer, if we made this a printer, then this same call here to turn on will call the appropriate method. So I wanted to touch on this topic real quick before we move on here, since we're talking about inheritance and composition. I think it's really important, especially in Java, to mention that you should be favoring composition. Basically, almost all inheritance can be rewritten as composition. We can find a way to make something that is inheritance composition. And I'm going to show you some ways to do this. It might not seem like this is true, but let's go through this and maybe you'll see what I'm talking about here. So one of the problems with object-oriented programming, it's kind of changed. The idea behind it has changed. Back when it was first used, a lot of inheritance was used. Now it's more composition, because object-oriented programming was originally about modeling the real world, and we found that that doesn't quite work out all the time. It's still good, it still helps us, but really what object-oriented programming today is about modeling interactions in a system and roles and responsibilities. And however you can do that, what makes sense inside of that system, that domain that you're creating, it really is how you should model your classes, not exactly after physical objects and what exists in the real world. And with that knowledge, you can divorce yourself from the idea that the is-a relationship has to be implemented in terms of inheritance. And this is kind of opposite of what I had talked about before when I said, well, is-a is inheritance. There's a way to rewrite is-a so that we can actually make it a composition. We can make it a has-a. And one way to think about that is we can take an is-a relationship and we can say that same relationship has a implementation of something. So for example, if we took our example of an animal and a cat, well, a cat is an animal. We could rewrite that and say a cat has an implementation of animal. So we're going to put an animal implementation inside of cat so that cat can use all of the methods and all of the functionality that's inside animal, but it doesn't have to be one. And this distinction is really important for one main reason, which is inheritance is really difficult to maintain. A lot of the messy code that we've inherited over the years is because of inheritance itself being used in that code base. I know that I've personally worked in a lot of code where inheritance was overused, and it makes things really difficult because when you make changes to a base class, especially if you have a large inheritance tree, those changes ripple down and they cause breakage in all these subclasses. The same doesn't happen so much with composition. With composition, you kind of know what you're in for. So that's just some basic advice to try and favor composition. And I'm going to show you some ways that we can do that using what we're going to discuss next, which is an interface.